Imagine a world where everybody can fly safely, door to door, meaning every middle-class family being able either to own or to rent an aircraft whenever you need it to do exactly what you want to do. That will be a world very much different from our world today, because flying private will no longer be a luxury. Flying private door to door will become part of a daily reality to billions of people around the globe.
From Airheart Innovation Series, this is What Follows with Nate Thuli.
Hello, everybody. Welcome to What Follows, the podcast where we explore the people shaping aviation today and the ideas defining what comes next. I'm your host, Nate Thuli. Today, I'm really pleased to have on our show Johannes von Thadden, the CEO of Draco Aircraft. Draco is working on a certified next-generation hyperstall aircraft and bringing that to market, pushing the limits of what high-performance backcountry flying can look like for the next generation of pilots. Johannes brings a remarkable background to that mission, from senior leadership roles at Airbus, serving as the CEO of Airbus Poland, to earlier leadership at Airbus Global Space Business, and even a chapter in politics as the Director General of Germany's Christian Democratic Union. In this episode, we explore his journey in aviation, the vision behind Draco, the growing momentum in the future of travel and safety and accessibility, and everything coming together for that. So let's jump in. All right, Johannes, welcome to the show. Thank you very much for being on.
Thanks, Nate, for having invited me.
It's, I've been seeing a lot of exciting news about Draco over the years. And, you can't be in the world of extreme flying or backcountry flying without coming upon Draco. How's it been going? How's the plane coming together?
Well, we are making progress. As you rightly mentioned, in the world of extreme flying, Draco is a known aircraft. And this thanks in particular to Mike Pady, who some years ago bought a Wilga aircraft that was produced in Poland, brought it to the US, and transformed it to this much more powerful beast called Draco that can take off and land in less than 100 feet, just the length of a basketball court, on
That's
pretty
incredible.
much any surface without needing concrete runway, not being dependent on any existing infrastructure. And this aircraft drew quite a lot of attention right from the beginning on. Mike won several prizes as the best type of short takeoff and landing aircraft, be it in Oshkosh, be it in Alaska. And I at that time was CEO of Airbus Poland, one of the big subsidiaries of Airbus. And you might wonder what Airbus has to do with a little aircraft like Draco, because Airbus is known for much bigger ones. So Airbus had bought a company in Poland pretty much 30 years ago, the oldest and most traditional Polish aviation company called PZL. And the reason for this was that at that time, Poland had just joined NATO. Poland needed modern warfare equipment, including aviation equipment. So the government decided to buy a mid-sized transportation aircraft from Airbus, but insisted on that the maintenance should be done in Poland. So Airbus just looked around how to do that, ended up in buying this company, and it bought this company with everything that this company had, including all the intellectual property rights of 100 years of aviation history and tradition. And this included Wilga.
Okay, that's
Wilga,
how those stories come together.
That is how slowly things come together. Wilga is the most successful aircraft built in Poland after World War II. Designed and built in what today is Airbus Poland, sold over 1,000 times all around the world, including to Mike Pady.
Right.
But Airbus has, of course, no need for such a small aircraft. So to cut a long story short, we discovered that Mike had done this fabulous work on Wilga and reached out to him, asking him whether he can imagine to market this wonderful aircraft together. And this is how we came to start realizing the idea. Finally, I set up my own company because Airbus was not interested, as this aircraft doesn't fit into the Airbus product philosophy for understandable reasons, by the way.
Of course, yeah.
So, and I decided then that, well, then I'll do it myself. I found a partner. We agreed with Mike on how he wants to contribute. And that is what Draco Aircraft is today.
Wow, that's incredible. I didn't know the interweavings of the subsidiary and that dynamic. That's fascinating. So going back a little bit to your background personally. So Airbus Poland CEO, certainly politics and then the entrepreneurial side, getting into this venture with Draco and bringing this plane to life at scale. What drew you to aviation? Let's go back in your past a little bit. What started all of this?
Well, I was not born swimming in kerosene. In contrary, actually, aviation, the fascination for aviation hit me rather late in my life. I had a career in different business functions in Germany and other European countries. Then I became Director General of the German Christian Democratic Union, Germany's biggest political party, and was responsible for the campaign that made Angela Merkel Germany's chancellor for her first term. And from there, I got the question of whether I would be interested in joining Airbus.
Wow.
But not the aviation part, but my ambitions at that time went much higher. It was the Airbus Space Company.
Interesting.
That asked me to join Airbus. So, and therefore, for a decade, I was flying much higher.
Right.
Than Draco.
Literally higher aspirations than
higher, being member of the board of this multi-billion space company, building launchers, satellites, being active in space-derived service products, and so on. A super interesting business.
Was that a largely on-orbit capability, or there wasn't a launch component to that, right? It was largely on-orbit capability then within that portfolio?
No, Airbus also produces its own launcher called Ariane, Europe's access to space.
Right.
So therefore, as a customer, you can buy whatever you need from Airbus. You can buy the satellite type that you would like to have. You can launch it with Airbus. We will get it into space. By the way, usually the legal handover of a new satellite is done in space and not on ground.
Interesting.
This protects the customer. If the launch goes wrong,
it wasn't turned over to the customer.
Still the launching company's satellite.
Right.
And it has a very practical reason. There is no value added tax in space.
Yeah.
So, meaning, at least not yet. And I hope that no finance minister will listen to our podcast.
Right. Yeah. Like, hey, that's a really good idea. We didn't think of that. Maybe we'll cut that part out. No tips.
So, and then what becomes increasingly important for every space company is that customers today very often do not want to own infrastructure. Meaning, if you are a telecommunication company or if you do farming or whatever, you do not want to own a satellite. And by the way, some defense agencies don't want to own satellites as well. What you want to have is the capability of the satellite. So that led to that companies like Airbus today do not only sell a satellite, but we would also keep the satellite in the ownership of Airbus, but just sell you the services derived from this satellite. And that today is a multi-billion business exploding.
Yeah, it's massive.
Every direction that you can imagine, be it actually farming, providing wine growers with information on whether they need to water their vineyards and whether the grapes are ripe for being harvested or whether they should wait, including defense-related issues, meaning there are certain parts in Afghanistan where you would very much like to know what is being grown there. Mm-hmm. And not all of this is legal.
Right.
So all of this today is space business or environment protection. So reforestation programs need to be monitored. If farmers or companies get subsidies for reforesting a region, you need to know whether the forest is really there. This is being done today by Earth observation through satellites. Okay, and that was part of my former career doing this.
Sure. Wow.
And I hope you feel that I still like.
Yeah, that's fascinating. And it's what's interesting to me is the departure from launch and on orbit capability and the services there to then down into really as tactical as aviation can get. With Draco, you're not talking stratosphere or low Earth orbit or geo. You're talking in the bush, in the backcountry, where there's often not even infrastructure, and it's this extreme intersection, if you will, between performance and then just pure flying experience.
So that is where actually the link is. So some years ago, Airbus asked me whether I would be interested in becoming CEO of Airbus Poland. What is an aviation company, basically? A little bit of space, but the vast majority is production of aircraft for the Polish military forces and producing parts for the civil Airbus fleet. So that is the big business there. So that was a totally new challenge.
Yeah.
Very much closer to Earth.
Right.
In every respect, because if you want to deliver an aircraft to a customer and on the day you want to deliver, you detect an oil leakage, it is pretty obvious what needs to be done. You need to find the source and fix it.
Right.
And when you go home late in the evening and it's fixed, then you know that was a good day.
Right.
If it's still leaking, you know that your next day won't be better.
The cause and effect logic is a little bit easier to follow,
So, but it's easier to fix than when you get a problem with your satellite.
Yeah, very much so, very much. So then now going into Draco and what you're doing today with that, how would you define sort of the mission of this next chapter? We've talked about it kind of in other conversations we've had outside of this, but for those listening, for those watching, where does Draco come into this from a mission perspective?
I think that is where we find a bridge between what you do in Earhart and what we do in Draco Aircraft, because Draco Aircraft is not only a hyper-performing engine for backcountry flying. Yes, that is also a purpose, and there are many customers waiting already to be able to buy such a performing aircraft. But what we want to achieve is more. We want to make flying private aircraft safe. You will know that flying private today carries an up to 500 times higher risk than flying commercial. There are over 1,000 accidents each year in the United States alone with privately owned aircraft. Whereas, and thanks God, there are literally no aircraft accidents with commercial aircraft. The reason for this is mainly pilot error. People flying an aircraft in weather conditions where they shouldn't be flying, overestimating their skills, and what have you. And in some extreme cases, because they might suffer from a stroke during the flight and can't control the aircraft anymore. So we will change this because Draco will be, and that is the difference to the prototype that we already have, thanks to Mike Pady. We will equip a Draco with a safety backup system assisted by AI, which will land the aircraft safely by itself.
Incredible.
And this opens a door to a totally new world of flying, fully autonomous flying. So what we want to achieve is we want to take safe and autonomous transport on ground to literally to the next dimension, to safe and autonomous flying. What, if you think ahead, will finally mean that people can fly, first of all, wherever they want to go. That is why you need a hyperstall aircraft. And secondly, they will be able to know that they can take their family, their friends, business partners along without being afraid that something bad would happen to them.
Yeah.
So this will be a revolution. And the question is not whether this revolution will take place. The question is, how long will it take us to make it happen?
I love that. I love it. And the imperative of that from the safety, and you didn't say accessibility, but it's woven into there, right? When you solve the safety barriers in a way that not only doesn't compromise the performance of it, but actually you're talking about longer range travel and diverse runway and terminal requirements and really even lack of requirements. It breaks down a lot of barriers between what prevents people from getting into aviation, doesn't it? And then having that ultimate
well, as you
backup.
know, today, private aviation is still something for a rather restricted group of people. That is, by the way, how each industry and each new product set out. Driving a car 100 years ago was a luxury.
Mm-hmm.
Flying from London to Paris 100 years ago cost you more than a 6-digit income today, if you compare it with purchasing power.
Sure.
At that time. So this revolution that we are talking about, safe and autonomous flying, will have several consequences. First of all, it will allow people to fly door to door that today cannot afford it because the price will go down.
Mm-hmm.
Secondly, we will see more traffic and less accidents.
Mm-hmm. Yeah.
And this, what might sound as a contradiction, is only possible if you introduce autonomous flying, because that would make the use of flying corridors much more efficient than it is today. So, and if you do that, you do not want to fly to LaGuardia or to O'Hare in Chicago.
Mm-hmm.
Because that is probably not even where you want to go to. With an aircraft that can take off and land pretty much like a helicopter, you can land on any supermarket parking lot,
Right.
Literally speaking, So maybe we should move some cars before we land there. But if you just imagine how much space we have in and around of cities and villages that are not really used, this opens a new way of transport.
Yeah.
So if you do that, then we need to talk about a third requirement. If more people do that, you can't do this with conventional engines, or you shouldn't do it.
Sure.
Finally, with conventional engines. Then you need also to solve the issue of electric flying. This is much being talked about today. Electric vertical takeoff and landing experiments, I would call it, draw lots of attention. People, venture capital funds and others are investing billions. But if you look at reality, not much has yet been achieved if you look at it from a commercial side, because what you see are all these fancy little videos where an eVTOL takes off, it flies a little bit, and then usually the video ends.
Yeah.
Because they never show you that this eVTOL can't get you where you want to go.
It comes right back down.
It comes right back down.
Yeah.
And here, what we need is another revolution, in particular in storing energy.
Yes.
So this will happen. It hasn't yet happened.
Yeah.
And therefore, VTOLs are burning literally billions in investment, whereas an aircraft like Draco can get you 1,000 miles. If you want to go as far, it can get you safely back and forth. And in the next generation with an electric engine, you will really have an environmentally friendly way of flying to where you really want to go to.
Yeah. And I want to pause on two things that you just brought up, because there are kind of laws of physics that are opposing some of the ways aircraft are coming into the world. And when you look at a vertically taking off, helicopter, eVTOL type of a thing, there are two fundamental barriers that Draco is approaching differently. And one of them being what you're talking about from the energy perspective. And I agree with you, as that continues to modernize, that will create the innovation and the demand signal for that revolution to get there. And so we're working towards that, of course. But for now, an empty battery weighs just as much as a full battery. And so when you're when you're depleting your stored energy, the benefit of a liquid energy source for now is that your aircraft gets lighter, you get, compounding benefits in terms of range. So obviously one difference there, but the other big one is when you go from a vertically lifting configuration to a fixed wing configuration. In the case of Draco, you have found a way to have hyper short takeoff while being a fixed wing aircraft from the beginning. The range you can talk about there is phenomenal. 1,000-mile range. That is far beyond what an urban air mobility style, vertically taking off machine can do. And so you're solving a point of pain that is really fascinating, because often we want to take off, but then we do want to get somewhere, right? And fundamentally, if the destination was very close, there are ground options that will get us there. And it's fascinating to me how you've taken those kind of physics limitations and stretch the range so far. That ends up being a very usable utility when you have that type of range. And then you haven't talked about it yet, but I think a fair amount of carrying capacity too throughout that range, right?
Sure. So to start with the range, if you compare it to what I would call a normal aircraft of this size or to a helicopter, Draco can fly 2 to 3 times farther than they can do.
That's incredible.
Compared to a helicopter, our climb rate is double as high. What is relevant for the military in particular? Because if you are in a dangerous zone, you want to get out as quickly as possible.
Right.
Or in, if you need to fly a mission. Yeah? And compared to the life cycle cost of a helicopter, Draco will be significantly cheaper, less than half, with much shorter maintenance turnover time span. So the net usability of this aircraft is much better than in a helicopter, and it's safer, or even today. So, and if we look at this from a pilot's perspective, if you want to fly wherever you want, you need to think about that you need to get there and back. And where you want to go to, you do not want to be dependent on ground infrastructure, including battery charging or kerosene. So having a 1,000 miles makes you free to go wherever you want within a 500-mile circle.
And back, right.
So that is really far. And that is what makes this solution attractive. So we are discussing with the world's best electric engine providers, and they are really top of the notch. I mean, there's nothing better you can get today. What they tell us today is that with existing technologies today, they can offer us 1.5 hours of flying.
Okay.
First of all, that means that you can go maybe 30 minutes in one direction, 30 minutes back, because you definitely want to have a bit of reserve.
Yep. And I don't think you're going 1,000 miles per hour. So
no,
we're losing range.
You do not go 1,000 miles per hour, so it might get you to the next supermarket.
Yeah.
Well, that is not really why you would like to have such an aircraft. So, and now the shocking point is that if we would like to extend this to 3 hours of flying with the best technology available today, the batteries would weigh 4,000 pounds. That is the weight of the aircraft. So, meaning, quite obviously, it doesn't work. So, not yet. So what we need is a guy waking up one morning, coming up with a wonderful, revolutionary new idea how to store energy. It will happen one day.
Absolutely. Yeah.
So, but whether it will happen in April this year or in April 2030 or 40, actually nobody knows.
No, not yet.
And that is a basic issue everybody in the aviation industry is fighting with. So there are things that you can do as a step-by-step approach. You can make your kerosene a bit more environmentally friendly in using renewable or naturally grown energy. You can make your aircraft hybrid. That already is a good step to do. But the dream of real freedom by flying electric is a revolution that we really need to work upon.
Right.
But Draco wants to be part of this.
Yeah. As do we at Earhart. This is where there's going to be some sort of fundamental shift in the technology that gets us there. And in the meantime, it's about advancing the surrounding infrastructure. It's about advancing the surrounding technology so that when that stored energy revolution can happen, and certainly we're getting massive demand signals for that from the automotive industry as well. The amount of EVs that are coming into the world, and I may be a little bit biased driving around here in Los Angeles because it's a bit of a hot spot for EVs as it should be, as you would expect. And my goodness, they're booming. And with that, a surge in demand, a surge in innovation and the technology for that. And hopefully we'll see that make its way into aviation here.
No, and if you allow me to say, as you say that you are a little bit biased with regard to Earhart, I'm not. So therefore I can say that is what got me interested when we talked for the first time, because what you are working on goes into the same direction, trying to solve urgent issues for the future of aviation. And what you do will have a great impact on how aviation will look like in a few years from now.
Yeah, thank you. Yeah, I mean, I think the reason why we call the podcast "What Follows" is, when you pull back things to first principles and you apply some sort of future-oriented push on top of that, it's very exciting to see what follows, and to see what can come of that. And certainly, yeah, there's a lot of common ground here at Earhart on safer and more accessible. That's what it's about at the end of the day. And and we can get there.
And that is why we think that short takeoff and landing, safe and autonomous flying, the question of how you do that in an environmentally friendly way, this all belongs together. Because if you want to fly autonomously, this needs to include the freedom to fly where you really want to go to. Otherwise it's not only half the fun, it is also only half the way.
Right. Yeah.
And at the same time, making flying really safe is still an unsolved challenge when it comes to smaller aircraft. So there is no reason why we should accept that people die in small aircraft accidents each year. It's the technology today is at the brink of being available. And that is why it is now the right time to get it done. And the experience that we make is that this is a convincing story. It attracts investors. So allow me to say, US Venture Capital Fund is our first investor, and we just started negotiations with a second investor who made us an oral offer to invest into Draco Aircraft.
Great.
So it is also for us, of course, an important signal that the market is ready for these solutions.
Yeah. So first of all, congratulations on being able to continue to grow this. As we're looking at what this future state looks like, one thing that we've been talking about internally at Earhart, and I'm sure it's been coming up in your conversations at Draco as well, is, you look at the use of new technology and novel technology and the use of automation and the use of sort of these fundamental levers that will enable a safer and more accessible future of aviation. We can't help but think what it means to be a competent pilot, what it means to be the aviator that's commanding that aircraft, will be evolving over time as well. And we look at the automotive industry as an interesting parallel. Obviously, there are a lot of differences. First of all, being in a car, you can just pull over or put your flashers on and slow down. We don't have a pause button in an airplane in the same type of way. But day to day, we see drivers of 30 years ago had needed to have skills that drivers today don't necessarily need to have anymore. The ability to park a car on an incline with a manual transmission and then parallel park it without backup cameras was something people needed to know how to do, 10, 20, 30 years ago. Really, you'd have a hard time finding a new car today that would expect that of a driver,
And Nate, we should not forget that when we look at your example, that too many people 20, 30 years ago turned out not to have the necessary skills.
Sure.
And that is why the number of fatal accidents, car accidents, 20, 30 years ago was much higher than today.
Right.
And what we see, and it might be a bit counterintuitive for some of those who listen to us, is that when you look today at autonomous driving, so for example, Waymo and their taxis, the rate of accidents is lower than the rate of accidents by real people driving a car. I hate it because I like to drive.
Same.
So, and when someone were to tell me that there is an AI-supported solution that's might drive my car safer than I can do it, well, at a first glance, I might not like this message. But it is, first of all, it's simply true already today.
Right.
And secondly, I am very glad that I don't need to do these things that 30 years ago we all needed to do. So if you remember how many marriages came to the brink of divorce because driver and co-passenger could not agree on whether you should now turn left or right. So we forgot about it because today it's quite obvious that we do not ask our co-driver
with a printed MapQuest.
Yes, with a printed plan that never falls the way that you needed it, and then you couldn't read it or whatever. So it was awful. Nobody wants to have this back. So, and the same will happen with regard to flying. Meaning, of course, you will still be able to fly your aircraft if you want to, all fine with it, and it's lots of fun. In a crisis situation, you will be glad that the aircraft offers you the choice to let the aircraft do what the aircraft can do better than you. We even do not need to take the most extreme example. But if you suffer from a stroke while flying, today it means that's it.
Yeah. Short of
for you and for everybody on board.
Yeah.
Already today we have technologies that allow the aircraft to detect your situation. As you have it already in your car, the car gives you a warning beep when you show signs of fatigue. Yes, or when you cross a line that you shouldn't. So the same will be in an aircraft. The aircraft will give you a warning. If you react to the warning, all fine, you continue. If you do not react, then the aircraft will take over, leaving you the choice to overrule the aircraft. But if you are incapacitated, you can't do that. And then the aircraft will fly you to a safe spot to land. And that is where short takeoff and landing capabilities come in as being not just a nice add-on, but in some cases as a need to be, because you want to land in this situation as close as possible to the next hospital that is where you will find help.
Yeah, and there are small airports everywhere, but not necessarily there, right at that moment.
So of course it is more complex than with a car. In a car, we have to solve basically two-dimensional problems, left, right, forward, backwards. So with an aircraft, you have an additional dimension. And landing an aircraft fully autonomously requires, among other things, a much more sophisticated navigation system, because it doesn't help you to know that there's a clear field where you can land the aircraft if you do not know that in the direction from where you are flying in, there's a tall tree.
Yeah.
Meaning the field can be as empty as it is, the tree will be harder than your aircraft.
Right. Yes, unfortunately.
So there are challenges to be solved, but having identified these challenges means that step by step, we will be able to solve them. There is today no longer any question that needs to be answered where you do not understand what the essence of this answer needs to be. And that means it's doable.
Right. Well said. I love that. So one thing that you're talking about a little bit ago as well is the system at large, and we see in the news all too often updates about air traffic control shortages and pilot shortages and the whiplash effect through the commercial landscape when there's overwhelm of demand for air travel and lack of supply on those that are necessary to make that happen, right? And so this closed system. And one thing you alluded to, and I want to unpack a little bit, is when you put autonomy into there, when you put intelligent technology into that closed system, what happens starts to be really fascinating. It came to mind on the drive into the office today, there's a stretch of road that is never all that backed up, but for some reason was just bumper to bumper gridlock. And it was unusual because it was, I'm used to pretty bad traffic in LA, but not usually in that spot. So it was, that's a little different, not what I was expecting. And sure enough, as I passed through that area, I saw there was a car accident, 2 cars involved, and they were still in the middle of the road. They had not moved off to the side. And so that's an example of where the flow of that closed system was highly disrupted by a departure from efficient travel, whether that is something as little as a driver making lane changes that don't seem logical or then causing small ripple effects through the system, or in this case, 2 cars completely stopped and broken down in the middle of the road is a much more catastrophic, kind of infusion of chaos into that system, right? And one thing that's really exciting when you look at technology going into planes that improves the efficiency and the decision making and the overall optimization of the air travel system at large certainly reduces the demand or reduces the strain on the total infrastructure, right? Is that something you're seeing as well?
Most definitely. So again, we might not like it, but again, looking at the experience we make with our daily driving of a car, disruptive behavior of the guy in front of you usually causes the traffic jam.
Right.
And then it goes back and back and back.
Mm-hmm.
The same is, of course, true in aviation as well. So there's so much efficiency that can be gained in using airspace. By the way, of course, we will need traffic control. People, meaning traffic controllers, will be able to survey many more aircraft at the same time because there will be a standardized flow of information, and the controller will have more freedom to look after those aircraft that he really needs to concentrate upon, because it will be shown to him that this aircraft does something that needs to be looked after, where the other 999 are just flying the way they should. There will be traffic control, of course, but in a more efficient and, again, when looking at the result, in a safer way for those who fly.
Mm-hmm. Yeah. And that's what enables aviation to be an accessible opportunity again, and even more so, right? When we can see that happen. So we've looked back into the past and we've looked at kind of what the automotive industry has seen and what drivers have seen from 30 years ago to today and some of the parallels into aviation. If you were to forecast out into the future and kind of imagine what some of these themes then play out 10 years into the future for aviation, and maybe by then we've seen a stored energy revolution that's enabling that type of stored energy, powering an electric vehicle in the air. We've seen autonomous systems optimizing the airspace, and we've seen just this plummet of accidents from the adoption of this type of safety and technology. If we see that come to be, what might be the most exciting aspect of that future of aviation for you? What excites you about all of that?
Whether that will be in exactly 10 years or in 9 or in 15, that remains to be seen. But imagine a world where everybody can fly safely, door to door, meaning every middle-class family being able either to own or to rent an aircraft whenever you need it to do exactly what you want to do. That would be, or that will be, a world very much different from our world today, because flying private will no longer be a luxury. Flying private door to door will become part of a daily reality to billions of people around the globe. And if we take what we discussed so far to the end, it means that to do that, you will not even need a pilot license. Because if your aircraft is fully autonomous, and if you decide on Friday that you want to fly with your family from, to the Grand Canyon, you will order an aircraft, and not at the next airport, but as I said, maybe taking
down the
off
street
from a supermarket parking lot. And this aircraft will get you where you want to go to.
Mm-hmm.
For a price that will be significantly cheaper than what we can think of today.
Right. Yeah.
So I think that is the potential that safe and autonomous flying has. It will open a market that goes far beyond of everything that we see today. So there are studies that speak of a $1 trillion market for this. Again, whether it's 1 trillion or 900 billion or 2
Sure.
trillion,
Yeah.
I don't care actually.
Who can speculate?
But it is a new world with integrated technologies that provide us with freedom that today we cannot imagine. And that is what we in Draco Aircraft are dreaming of, to become not only part of this, but to be one of the drivers of this technology. Yeah. So, and again, what is fascinating about it, if you can do that while keeping people safe and safer than today,
Mm-hmm.
I think that is worth every effort.
Yeah, absolutely. And that, I don't know about you, but that's the future that gets me pretty excited as well. So that let's see what we can to do to make that happen. This has been wonderful having you on. I really appreciate the conversation. Before we drop, any parting thoughts?
Yes, Nate. First of all, thanks for having invited me for this discussion. And I'll keep my fingers crossed for everybody who drives this revolution ahead. And I wish that Erhard will be a strong part of this alliance for the freedom to fly wherever you want.
Wow. Well said. I love that. Well, thank you. Thank you very much. And we wish the same for Draco. Thank you for being on. Thank you for what you're doing for aviation. And we'll talk again soon.